today we're talking about data. This is sort of a data visualization course, even though it's called visual analytics. Data is a very important part of our course. I consider this to be a very important lecture that impacts all of your work in this class and beyond. So please pay attention. It's an important lecture. So today we're going to talk about data types, data sets in general, and how we think about mapping those into visualization, creating visualizations from them. What do you think this means? This list of numbers that I'm showing you. What do you think it's referring to? Any guess would be good. Height? That's a good guess. Any other guesses? Could be weight in pounds. Set of odd and even numbers. Okay, how about this? Yeah, this is years, but might be specific years, right? Might be years that, I don't know, I was in high school or something, or I was in college. Birth years. It could be birth years, exactly. How about this? It's more ambiguous. Survey responses to something. How about this? Cities? Yep. But can you guess what these are? What cities are these are? Could be birth cities of people in this class, at least some of us, right? Or places that I have visited, or cities I've lived in. Could be any of these. Similarly, another set of data, thoughts, current mood. Yes, I more sad than happy or equally sad than happy, but these are yeah, emojis Maddie's dad sent. Anyways, another data set could be this. It's gotten worse. It's definitely gotten worse. It's gotten better. Could be answers to the question, has the world changed from 1950 till now? Or it could be, how's 2026 in comparison to 2025 so far? And lastly, what do you think this is? Just a moment. Yes. Isabella, is that okay now? Cool. So what do you think this list is? Artists, music artists, different artists, but yeah, it could be favorite music artist, or could be my favorite music artist, or it could be the concerts of favorite artists that I've attended. The reason I'm showing you this is that data sets like this are, it matters like what the meaning behind these columns or these data sets that we were talking about is. That influences how we interpret these information. So we generally don't look at data sets like this just as lists with commas. We sometimes organize them like this. So now it's becoming easier to, even by this organization, it's becoming easier to think about. We have names here. We have, I think, age. We have favorite band. We have favorite food, probably. So these are the meanings of these data that we're looking at. I'm spending time here for you all to get into the habit of thinking about what is the data that you're looking at, right? Very specifically, right? So this fish and chips is probably Amy's favorite food. Taylor Swift is their favorite band or musician. Then age is 30. Okay, so real world meaning, the semantics behind data is important. And then another thing is that what is the type of the data, the thing that we really care about, right? Structural and mathematical interpretations of that data, right? If it's years, we treat it differently than just plain numbers, right? And then it's important to think about how people break down these different data types and think about them. And this influences how we do programming, which you all are going to do. So one of the ways that we could consider data sets is in a table, right? And in a table, we usually have rows as items or objects, and then we have columns as attributes or variables of those objects, right? So the way we talk about them is that, for example, 9-inch nails is an attribute of this object, which has the name of Ali Reza and the age of 22. These are attributes or variables associated with that item. Okay? So in general, we have rows as items and then columns as attributes of that item when we treat something as a table. However, how we put data in a table matters. So, what do you think is the problem with this table? First of all, what is this table? It's a table of movies. Do you find a problem with this? It's hard to scan easily. It's hard to say the movie Inception has actor one, actor two, actor three. There's probably more, right? Is this the best way to represent this data set in a table? What if we did this? What if instead of just having one row for one item, we had one row for each actor associated with a movie? So now we can easily say, okay, all the Inception actors, each of them have one row, and then we can easily know their role, know the release year of that movie, and then do stuff with those names. This data set, the way it was represented, is called a wide format data set, meaning that you have a lot of different columns and then you have to deal with it, right? But this is a long format data set where you can access rows by movie or by actor or by role. You don't have to do actor one or actor two. So this is usually a format that's better for visualizations, the long format where things are organized atomically. And data is not always presented in a table. So what we've been looking at right now has been mostly tables, but sometimes we have spreadsheets or relational data sets that look like tables. For example, we could have multiple tables that are related to each other by certain IDs. If anyone does databases, you will get used to these types of databases because the world is complicated. So you can have, for example, on social media, you can have users in one table. Their posts could be another table. And then for each post, you need to know what the user is, so you can associate the post with the user ID in the user table. And then you can also look at who's following whom by having a separate table. So this is called relational data, where you include relations between items and objects as IDs and link them together. A lot of the internet looks like this. JSON format, where if you're familiar with JavaScript, which you hopefully should, or Python, see that these are dictionary data formats where we have keys and values for each of the items. Essentially, we have arrays of objects and then we can have key and value pairs in that. This is another semi-structured data format. Tables are more structured than JSONs are semi-structured because there is some structure, but then you have like more for each object, you can change the key and value pairs. You can also have XML, which is another semi-structured data format that you're all going to use a little bit of it, even though it's a really difficult format to deal with. But it's used, for example, in HTML, which y'all are going to use and learn about. We also have unstructured data. Unstructured data is data that has no format in it. So an email, a body of text, the chat that you send to ChatGPT to answer your questions and assignments in this class, which you shouldn't, is unstructured data. Unstructured data or any data that can have metadata about it. So you might have a piece of text as an email, and the metadata, the things about that email, which is not the data set itself, can be who's it from, who is it towards, what's the subject, what's the date. These are metadata about that. And given all of this information that you just saw, that data can be structured in different ways, we often, as data scientists and people who deal with data, have to do data wrangling to change one data format to another so that we can make sense of it better, maybe use it in a software that works with that data set to make it ready to be used in a specific way. That's why we spend a lot of time with data wrangling. For example, we can change an unstructured data to a structured data by doing some work on it. For example, if you are looking at text about inception, for example, you can do this. You can take all the words and count the unique occurrences of those words. And then now you have a word count data set that's derived from that text. And then you know the is the most frequent word in this text. And then inception is the other one, and then so on and so forth. This is a form of data wrangling that you could do, changing formats. But now the notion of data, the way we format data and store data, and how we can wrangle and change formats to each other aside, one thing that's really important for data visualization is data and variable types. Let me get some water. So data types are nominal. And we'll see examples of that. For example, color, which is red, blue, green. We have ordinal, for example, classes, freshman, sophomore, or junior and senior. Again, let's look at all three and then we can practice on these. Days are ordinal. You can have quantitative data sets. Numbers, things that we can do math on. Okay? Nominal data sets, the way you can think about them are basically when you have like different categories. They're also called categorical. Categorical data sets are all over the place, right? For example, the country one is from is a categorical data set. It's nominal. If those categorical data have an inherent order to them, then they're ordinal, like class or days of the week or weeks or months in a year. These have orders to them. So when you organize them, you can sort them. When you can sort them, that means they're ordinal. And then quantitative is anything that you can do math on them. For example, age, height, and counts. So these are the three main types of variables. Could be, yes. Ordinal also has ambiguous intervals in between values. It could be. Usually, though, the way you think about ordinal is that it's categorical, that has orders. So there's like really no values, but you could consider anything ordinal as long as there's an inherent order to them. Okay, so look at this chart and tell me what is this? What is the data type of these different lines? Yes, but what's the data type? Ordinal, nominal, categorical? Yeah, this is nominal because it's categorical. This is numerical because these are numbers. You can add them or sort them. This is categorical. This is temporal. Temporal is a specific type of ordinal data. We have more than just those three. So what type of data is this? There you go. Ordinal. It's really important to know what type of data you're looking at because you will know how you can deal with it. If you see ordinal data, then we can treat it as ordered and do sorting and help people see it in an ordered way. What type of data is this? Absolutely, quantitative. Thank you. What type of data is this? It is nominal, but is it also ordinal? I think so. There's an inherent order. Warm can be in between cold and hot. You can have more items in here, but what type of data is this? Yeah. Very good, everyone. This is easy, but it's good to practice. Okay, so now besides those data types that we just practiced, we have a different way of representing these. We can represent data about objects in a one-dimensional way, 2D, 3D, many dimensions. We can have temporal, we can have tree, we have network types of data sets. We'll get to this, right? But let's look at this idea of semiotics. We're moving into data sets and how we can visually represent them. The idea is that images are perceived as a set of signs where the sender encodes information and then the receiver decodes those signs. It's a very simple idea, right? And we do that with visualization. The way we encode data into signs is through viz composition. The first thing that we use is the spatial substrate in a 2D space where those items are located. The second thing that we use to encode that visual data into visualizations is marks. What do we use to represent the data? What shapes do we use? Do we use a line? Do we use a rectangle? Do we use a shape? Do we use a 3D object? Okay, so spatial substrate is the physical space, like on a map. Then the mark is how you represent it, and then the graphical properties of those marks. So if you have a circle, you can change the size of the circle. You can change the color of it. You can change the shape of those marks. You can change the orientation of them. When you do visualization, this is how you should think about it. How am I representing a data set into these attributes, into these visual compositions? How am I mapping a data into position? What mark am I using? And what graphical properties am I changing? We're going to practice with these types of thinking about data and visualization a lot because this will turn you into a visualization expert. In a sense, instead of saying, I want to make a bar chart, which is like the noob way of making a visualization, you're going to say, I'm going to use a rectangle as a mark, and I'm going to set the height of those rectangles, which is the graphical property of that, to one specific data set. And we're going to practice with this a lot. But I want you to think about this way of thinking and get familiarized with it. Size, shape, color, orientation, opacity, texture are some of the visual properties that you can use. Now, we are going to have a whole lecture on this, right? But this idea of getting data and encoding it in a sign, right, is not something that's equally important, effective. So some of these encodings are more effective with IIs for some tasks that we do. So again, we're going to have a lecture about position. For some data types like quantitative, position could be better in terms of reading that data, in terms of being more effective. For nominal, hue is next, right? But for quantitative, hue is really hard to read. So it's important what graphical properties we use. We do not just use any random graphical property. So now, besides the graphical property, another way we think about visualizations is how many of those variables for each of these items, remember the table with items and variables, how many of them are we visualizing? Is it a univariate visualization? Is it a bivariate? Is it a trivariate or hypervariate visualization? So thinking about this data set that we just looked at, we can pick any of these and make visualization, right? So we can pick any of these columns. So bar graphs, for example, or line graphs. Oh, and no, we can ask questions, but no special announcements. We're just moving everything to next week, right? So bar graphs and line graphs are univariate visualizations. For example, the revenue of each movie in a bar chart can be a univariate visualization. This was a horizontal bar chart, or this is a vertical bar chart. These are all univariate. A bivariate representation is when you see the relationship between two variables. So for example, you can make a chart about the relationship between age and how bald a person is. That makes it a bivariate relationship. So in a scatter plot, you can represent, for example, the budget and the revenue of movies. Okay? So univariate we learned about, bivariate we learned about. Now we're getting to trivariate relationship. So any ideas about trivariate relationship? So we learned about scatter plots, right? Absolutely. Stacked bar graph is one way of doing a trivariate relationship. So you could basically, for each item, if the three of them are quantitative, then you can make a stack bar graph, and that could be a trivariate. But you could also make a scatter plot. However, there are better ways. One of the things that I want you to take away from this class is we generally don't do 3D visualizations unless we have to. It's a bad idea. You'll learn why. Yeah. We don't want to do 3D because it's harder to read. Okay? A better way is to mix encodings. So you can make a 2D scatter plot, then use a third channel to represent the third variable. Something like this, where the x-axis is the budget in millions, the y-axis is the box office revenue, and the size of the circle is marketing budget. Okay? Let me open some Figma and do some drawings for you so we can be sure that we all understand this. So we're going to practice together making visualizations the way we just talked about it, right? So I really find this important for you to practice thinking in these lines. So let's say that we want to visualize the marketing budget of these movies. What type of visualization would be making? Univariate, bivariate, when we're only doing the marketing budget. Univariate. That is correct. Okay, so what would I make? I would like to use the rectangle mark to represent with the graphical, so rectangle mark. So that's how we're representing each item. The data will be marketing budget. And the property that we're going to use to represent each of these is the size of the rectangle to represent marketing budget. And then the other property that we're going to use is we're gonna use the y-axis to set the movies, which is a categorical data. So we can order them here. So it can be Inception here, Dark Knight here. So Inception, right? So we can order them. And then for each of them, this is 100. So let's say, boom. And then, boom. Is it making sense? Okay. So now I could totally use a circle instead of a rectangle and just do this. I could choose to pick circle as the mark and then do the size of the circle. Or I could just change the color of the circle. So I could just make this as my graphical object and then change the color to represent the size. I could do that. Is that a good idea? We're going to learn. But so here we're encoding the marketing budget using color or hue. Okay? So now you can think about univariate, you can think about bivariate, you can think about trivariate, or you can mix encoding. So you can use position to encode two of the variables, and then size to represent the third. Instead of size, you could use color to represent the third. You have creative freedom. What you choose to do is your expertise in visualization. In this class, this type of question is what we expect you to get better at. Not to make it's important to make cool and pretty and interactive visualizations, but how you think about your choices as a designer with the teachings that we're going to give you and the readings is the outcome of this class. Okay? This is another type of trivariate. You have X budget in millions, Y box office revenue, and then the line connectedness, what's connected to what is probably the year, which is a weird encoding, but it's also interesting. You can tell really good stories with the choice of encoding. So for example, if you show budget versus revenue of Martin Scorsese movie, am I being like a extreme boomer with using Martin Scorsese as a director of choice? Do you all even know Martin Scorsese? Anyone has seen any of his movies? I'm always like paranoid that I'm just, yeah, hell yeah. Taxi Driver is amazing. So, what do you think this movie is, the 2019 one? So, what's up with this like increase in revenue and then drop? That's The Irishman. Very good. Exactly. So we can tell an interesting story, right? We have movies that have smaller budgets and smaller revenues, and then we get into The Wolf of Wall Street that has a lot of revenue, and then we have The Irishman. Now, exactly, Shamik. That is the point. You can tell a story, but this does not mean that The Irishman was did not make money. It just means that it did not have the box office revenue. This was a Netflix only movie. And then the movie after The Irishman was what was it? Yeah, I liked it. I think that was a really good movie. Okay. Yeah, it was Killer of the Flower Moon. Yes. Okay. And so remember how we have these scatter plots, which we can connect. Maps are also basically the things that we are comfortable with are basically scatter plots. The X is just happens to be somewhere on Earth, but it's a scatter plot. And we can do the same thing. We can do the same encoding. Now, this is a visualization I created a while ago for a book of mine, where each circle is a position of protest in Hong Kong, and then you connect them like in the order for which the protest happened. So you can follow it. The protest started here, then they moved around, they went from 13 to 14, etc., etc. So you can do storytelling with how you choose to represent the data. So here the x is the x coordinate on Earth. We're going to have a whole session on maps. The y is the y coordinate on Earth. And then the connectedness between the dots is the year or the time or the date. Another way to do trivariate representations is to just have a little chart that represents each of the variables, and then you put them side by side. That's a really good strategy a lot of times. It's called small multiples or something, where you do something like this, where you have like bar charts that are organized in a way where you can read them for each item separately. You don't necessarily always want to do like a grouped bar chart, if you will. You can always do these sorts of organizations or facetings of charts. So this is a good way of reading this. But in general, hypervariate visualizations are tough to do. Lots of well-known options for these 1 to 3 variables, but it's often interesting to think about what you can do. But again, you can always do this, just putting multiple visualizations together. Something like this, where we have 1, 2, 3, 4, and 5 variables, I think. At least 6 variables for each film. The color, I don't know what the color is, but it's probably the season. because you can also group them like this. So this is one of my favorite visualizations. How many variables do you find in this visualization? List them in chat. Ideas? Let's not think about what they are. What different graphical properties are being used here? Your eyes can already tell, right? Don't overthink it. You have color, right? So you can see that colors exist. Different colors probably mean something. Position definitely exists. Great. What else do we have? There's probably interactions between them. But don't overcomplicate it. So we've counted position, color. We have shapes. What else do we have? I think we have size. We have the order the dog is facing. So if the dog is facing left, it's considered dumb. If it's facing, it's considered clever. The size is the actual size of the dog, and the color is I don't know, the breed of the dog or the type of, yeah, the type of the dog. And then the position also exists. Okay? So you can really go crazy with your encodings and how you represent things. Do you all prefer dumb dogs or clever dogs? Let's take a vote. All dogs matter. I agree. I like dumb dogs. They're cute. I agree. Yeah. I'm with dumb dogs. So we can take a look at these just so that this website is interesting. I really want you to take a look at these different visualizations. So let's do the same practice. Yeah, smart ones are for solo post-apocalyptic trips for sure. But I gotta say, when the zombies come, I'm not one to fight. I'll give myself up. I'm not a fighter. Anyways, let's not. I'm in a morbid time right now. Okay, what encodings do you see here? Color? Yes. Size? Do I see size? I don't know. Yeah, so the relationship is the link between them. Position, I think, matters. What else? Line type is one of the encodings we can use. Yes, solid versus dotted lines. Good. But we also have more. The text. We have whether it's a group or a nation, exactly, capitalized versus non-capitalized. There's non-Muslims. There's the color is whether the country's like the relationship is a love, is a hate. It's like a oversimplification of the relationships, but it's funny. So like looking at Iran right now, you can see, oh, Iran loves Hezbollah and a good relationship with Iraq, which is weird because they had an 8-year war. And then they have a hate relationship with the USA, but I don't know if that's true. So we can do cool things, right? India is okay. And then Islamic Jihad, love relationship, I don't know. Anyways, you can do a lot of cool things with these types of visualizations. Let's look at Turkey. Turkey loves Kuwait, loves Pakistan, do they? I don't know. Good relationships with most, but hates ISIS and hates Egypt. I don't know. Anyway, this is an interesting visualization for me. Let's do a third one. Just pick something and just do another practice, and then we continue. Okay, what topic do we like? I really information is beautiful. Let's just first pick from like the categories. Food, everyone? Okay, we have one vote. Okay, let's do world's best hangover cure. Okay, what are we thinking? I'm loving this actually. This is such an interesting visualization. So what do we see? We have colors, we have size, we have shapes, Exactly. So the size is the amount of in each item. So like we get more, yeah, the cup type is interesting. This is cool. Not, I don't think that was the food that we were. Let's do caffeine versus calories as well. So how much caffeine you take and then how much calorie. So we have shape, we have position, X and Y, and then I believe that the color of the text is also a representative of something here. Okay? So get into the habit of thinking in these terms. I think you will have fun if you do this too. Okay. Sometimes we just do table. We just show a table. Tables are sometimes good. A nicely designed table goes a long way. It's the most accurate way of reading the data for sure. However, as we might have seen before, it's harder to find patterns, but tables are important. So it's good for looking up specific values. It's good for comparing individual values. It's good for precise values, for tasks when precise values are required. The way you design or visualize data in a table is also important. These two are just super different. I think the one below is so much more easy on the eyes. But when we do visualizations, we can reveal relationships among values. So we go beyond the values and retrieving those values. And the message is contained in the shape of those values. Okay? So that's why we do visualizations. But we care about both types. Sounds good. We're almost done. I want you to think about now data cleaning a little bit. So when we get a data like this, it's really hard to work with. We need to clean it up to be able to work with it. So we do some data wrangling here. We reformat into a column to have statement, state name, property rates. How would you do this data wrangling? Any ideas? If any of you would want to clean this data, what would you do? You could write some sort of program. Yeah, I don't understand. What's the question? Oh, yes. They all shifted left. That's why you need to do the cleaning of the data. Yeah. So yeah, a lot of these things that we do with those data sets is to reformat it, to cleaning so it's usable by a computer, to do quality assessment, to integrate it within software. Okay? So you can write a custom script, you can do manual manipulations in a spreadsheet, you can clean the data manually. There are data wrangler. And nowadays, it's one of the things that just becomes so much easier. You can use AI to help you clean the data. Not only AI can just do some sort of data transformations in a really good way by AI large language models, you can just ask it to write code to do cleaning for you. So we have missing data problems, we have type conversion problems, we have resolution problems, which we have data integration problems. So let's look at some of these problems that we need to solve later with our data sets. So what do you think, what kind of problem this data set has? Any thoughts? Very good. Missing values. You don't have this data for some variables for some movies. So you either look it up and add it, or you find ways to fix this problem. Otherwise, your data set is going to be problematic. So you need to clean it. So this is missing data. Yeah, the decimal is also a problem. The data type could be changed. Very good. Okay? So what do you think this data problem is? It has missing data, but what else? Misspellings of titles, exactly. Typos and negative values. Both are correct. Yes. And we can't have minus 500 box office revenue. We have outliers. We have this Titanic, which has a lot of like too much box office revenue in comparison to everything else. The misspelling is there, so you all caught it. Yeah. The currency could be different. Exactly. Yes, exactly. Harry Potter can't flop that bad. You all caught all the problems, but then you will need to fix them. So what's entity resolution? Can you catch the problem here? Exactly. Very good. So you can't really use this director data because like you can count the number of movies for a director because Christopher Nolan and Nolan Christopher are the same person, but they are formatted differently. So you need to do entity resolution. That's another type of data cleaning that you need to do. And who's Chris Columbus? It's probably the director. And then you need to do conversion, right? You need to do, for example, location to an XY coordinate, or you need to get the revenue might not be in millions. So you might have to do a lot of different data conversions to get there. Okay, so we talked about data cleaning. The last thing is that this is the type of work that we want to do with visualizations to simplify and design a chart that communicates the core of what you want to do. So a lot of the encodings and the ideas that we talked about is to get you to create a very effective, nicely designed visualization that just gets people where they need to, right? I want you to look at it again because we're going to have a whole session on these types of works, but it's so easy for us to not think about these very simple design choices that you, through this class, by your knowledge of the data type and what's important and the storytelling, need to get to. Okay? So, in next sessions in this course, what I want you to get familiar with, first of all, is your deep understanding of what data set you're looking at and how you need to clean it. And then these ideas of encoding those data types into effective, nicely designed visualizations that tell a specific story or allow you to conduct analytical reasoning with. Okay, we're gonna do a Discord exercise. I want you to pick one of these ideas and post your visualization. Yeah, a thread for them to create. We're going to create a thread on Discord. Use any means that you can. We're going to take 10 minutes and then we're going to talk about them. But try to use the lessons that you learned, right? Just use any means that you can, like a hand-drawn or Microsoft Paint. I don't know if that's used, or Figma, and draw a visualization and post it for us. So we're going to take a look together and make your visualizations as weird and interesting as you can. We just want to practice thinking, like imagining a data set and then visualizing it. No, just one. Just pick one of these topics. We have the first visualization coming in. Oh, times I checked my phone last week. Hell yeah. Friday? Only three? Okay, this is great. Nice. So what encoding is this, everyone? What visualization specifics are we doing? What is the data type? We're going to take 10 more minutes making those visualizations. Wow, we have a new one. Each circle color different city. What is the title? Oh, trees? Okay, this one is cool. Times I read the news last week. This is absolutely, that's absolute truth for me too. So this is ordinal, numerical, or quantitative. So what are we looking at? Did I play Genshin? Beautiful. So a categorical data set, a variable here, times of the day, and did you play Genshin Impact? And you used line to represent it. So what was going on Monday, Tuesday that you didn't play it? Distribution of Canadian NHL teams by province. Didn't know how to display the number of teams. Okay, that's cool. Ontario, Alberta. So Ontario's got the most. Cups of water I drink. So there's no water. You're th very thirsty right now, huh? Just Tuesday. Okay. Times I fell asleep in an in-person meeting at work. Oh my God. Okay. Number of, is it a type of dog? Dachshunds in a city? I don't, das. Oh, dash hunt. That's, okay, that sounds. How do I pronounce this? Can someone speak up and tell me how I would read this?
Dash hound?
Dash hounds. Okay. So Chicago's got none? This is a beautiful visualization. I love it. Okay. Making food, sleeping. Group bar chart. So the rest of the week there was none. And yeah, there's more hours spent sleeping. Types of vegetables I ate last week. Spinach, cabbage, and then romaine lettuce. This is a cool visualization. Okay. I love all these. Food in body when. These are gold. Amount of sleep I got last week. Okay, so Friday night you were partying? Because I'm glad that you slept the rest of the week. Okay, time when I wake up. 12 p.m., 7 a.m. Good that our class is at in the evening. Friends made in each term. No friends, one friend, third term, and then two. This is a really good data set. Yeah, no, this is not a cumulative chart. This is, I think, total three friends. Week one, activities, game, work, sleep, doom scroll, school, sleep. I love that you are all very truthful as well. Walking dog, 10 a.m., 11 a.m. Man, we need to have a website for these. How many times I ate or snacked last week? 7 times and 3 times. That's good. Eating egg. So what's the size of the egg? The amount of it, like how many? The number of the egg. So I would say Monday you eat three, and then Thursday, Friday you ate two. Yeah, it could be how much you love that. Okay, I'm just gonna go and find weird ones because we're gonna leave in a few minutes. Amount of time driving in past week. I like how you used icon arrays to represent them. We have a cat visualization. Total time my cat was on my lap. Can you also post a picture of your cat, Amanda? We need to see. Is it a dog? I don't know. Okay. Oh my God, it's a black cat. Wow. Beautiful. Thank you for sharing the picture of your cat with us. I want to get a cat at some point. Okay. Time spent studying last week. 8 hours per day. Really? Consistently, huh? Student propaganda. We all believe you. But if you spend 8 hours per day for my class, I'll be happy. Anyways, okay. I like where this class is at. We're going to do this sort of activity just not only have to have fun, but keep track of our progress in terms of how we think about visualizations. This is a really important lecture. I'm going to post the video. You have access to last year and this year. So please think about this, try to get into it. Read the Monzner chapter. It discusses these. And then we're going to do Tableau next week. You're going to use this knowledge in Tableau a lot. Tableau uses this mentality, this design framework of visualizations. And yeah, is there any other questions? Nope. Fun class. Thank you. Actually, like your energy made me forget my own depressions for a couple of hours. So I am really thankful to you all. We are going to have another lecture an hour or so on Thursday at 6:30. So it's not mandatory, but I would appreciate if most of you, whoever can, joins. But tomorrow I will post last week and this week's lecture on YouTube, and then we can move it from there. And I'll see you, either me, both of us, or only Mehdi will see you next Monday with Tableau. Next week will be, you don't have homework due next week. Just read your readings and watch the video. This is a really important lecture, but you don't have homeworks due next week.
The lecture on Thursday, is that going to be recorded as well?
Every lecture and lab will be recorded. We post everything on YouTube.
Okay, so the Thursday one is just like supplemental.
No, you have to watch the lectures. You don't have to be there live. I would appreciate it if you're not there. We have quizzes from next week on the lecture. So you would have to watch the lectures either on your own or in class. It's not supplemental. It's mandatory that you watch it, but you could watch it on your own on YouTube.
Oh, okay, you're describing the Thursday lecture.
Yes.
Okay.
All lectures, even lectures that most Mondays won't have lectures. These 2 days we had lectures just because of circumstances. We just needed to fill out time, basically. Otherwise, you would have done Tableau today.
I just wanted to clarify because I think I was a little confused when you talked about Mondays. We will have lecture or sorry, lab on Mondays, no lecture on Mondays.
Most Mondays you won't have lectures, yes.
So most Mondays, that means most Mondays we won't have anything at all?
No, most you will be present. There will be labs. You will do live coding. Media and I will be here. We'll teach you stuff. It'll not be lectures just like how I open up a slide and do things. A lot of times we'll do live coding together. We'll learn some software. It'll be hands-on. You will come into class ready to work. We'll do in-class work. Yeah.
Okay, thank you.
Yeah. Okay. Any other questions? Feel free to ask your questions in Discord. And maybe why don't you post the second week slide as well? Okay, everyone. What's up with Zoro and Sanji? Okay. Obviously Zoro. I love Sanji, but Zoro is the GOAT. There's no discussion. I think the fact that what Zoro did in what was that arc called with the goat with the thriller bark just puts him in a different. Yes, let's start on 6:30 on Mondays. Okay, we're gonna stop.